Okay, so the first implicit differentiation problem, I'm going to take the derivative with respect to x of both sides of this. So I'm going to take the derivative. I'm going to put big, huge parentheses. I'm going to take the derivative one at a time of each term. The derivative of x to the third is 3x squared. I mean, that's easy. Power rule. Multiply by the power, subtract 1. The derivative of y squared, multiply by the power, subtract 1. It's the same thing. However, I'm taking the derivative with respect to x of y. The letters do not match. And if the letters do not match, you add on a dy dx. You have to take the derivative of the inside function, right? This is chain rule. Y has x's in it. Y is a function of x. I don't know what it is. I mean, it might be sine x. It could be x to the 5th plus 1. But there are x's inside of there that I have to take the derivative of and put it outside. Now, the derivative of the other side, right? You take the derivative of him, boom. Take the derivative of him, boom. Take the derivative of 7, you get 0. Now, I'm looking for the derivative of y. There it is. You just have to get it alone. So take this guy from that side and eliminate him. So he's not there anymore. Now I just get 2y dy dx equals negative 3x squared. Now, again, I need this alone. This is multiplication, right? Chain rule. You multiply by the derivative of the inside. So I have to divide the 2y away. So this goes away. And to make it look all pretty, well, I'll write it again. This is it. This is the derivative implicitly. I did not solve for y and take the derivative like I normally could. It's not, most of these, you just simply can't solve for y. So you take the derivative one term at a time, and you solve for dy dx. Now, this was an easy one. This was a very easy one. I only had 3 terms, and one of them disappeared. The derivative was 0. The next example I work is going to be much harder than this. All right, so the second example, this one is much, much harder. I have 5 terms. Doesn't seem that bad, but it's a lot to keep track of. And I want to point out that I have 2 different things that have a y. So when I take these derivatives, I'm going to end up with dy dx's. But this is what I want. I want dy dx. So I'm going to take the derivative with respect to x of both sides. I mean, I can't really fit it in the front of this. So there, throw it at the top. I'm going to take the derivative one thing at a time. If the letters are the same, if it had an x, you do the derivative like you always do. The derivative of x4 is 4x third by the power rule. If the letter is y, you still take the derivative like you always do. You just multiply it by dy dx. So the derivative of tan y, the derivative of tan is secant squared. Now, you don't have x, you have y. So the derivative of tan y is secant squared y, and then you multiply by dy dx. Why do you do that? Because the letters don't match, and you have to use the chain rule. That's how it works. Equal, now I need the derivative of 3y to the 5th. Again, x, y. The letters don't match. Use the power rule, multiply by 5. 3 times 5 is 15. Subtract 1 from the power, it becomes 4. Then, since you have a y, you have to put dy dx here. Now the derivative of e to the 2x. Oh my God, chain rule. This is e to the u. So the derivative of e to the u is e to the u times du, right? And I like to put it in the front. So take the derivative of the power, which is 2, and put it in the front. And then just write the thing the way it was. And the derivative of 9, yay, finally, at least one term goes away, is 0. So you get this big, nasty monstrosity. But what I said to you to do in the class notes is take everybody that has a dy dx and put them on one side. And everybody that doesn't, put them on the other side. So I'm going to start moving things. I'm going to take the 4x3 and put it on the other side by subtracting it away, right? Subtract it away. So it's going to come over here. I'm just writing it there. Don't think you can put these together. You can't, right? Then I'm going to subtract the 14 the negative 15y4 dy dx, and put that over here. So if you want to write it in the front, that's fine. I'd rather not. I'm going to keep secant squared y in the front. Dy dx. Take away 15y4 dy dx. This is a lot of writing in case you haven't figured this out. And this is going to be a lot of fun to put into web work too. I have 2e2x on that side. And I took away the 4x third on that side. Now I have one more move. This is the big move. I have a common factor. I am solving for dy dx. So what I'm going to do is I'm going to factor it out of the left side like this. Just take it and put it in the front. And what am I left with? Secant squared y minus 15y4, right? This is your big move. This is still on the other side. Now I'm going to divide this away, right? You have to divide this. I'm running out of room, so I have no choice but to do what I'm about to do. This is going to divide to underneath that. So I'm just going to put it there in the next step. This is still there. The 2e2x minus 4x third. So I'm going to divide this. You divide both sides by this. So now it goes underneath here. So you put secant squared y here minus 15y4. Right? I divided it away. Poof! It's all gone. So this is what dy dx is. This is the derivative of y. Dy dx means the derivative of y. That's why it says dy. Derivative of y with respect to x. Take a good look at that answer. That's ridiculous, right? You guys still think it's easy? Rubiat said it's as easy as 2 plus 2. It's not. These problems are incredibly nasty and long. I mean, look, I didn't do one that's that hard. and you know, you can see this answer is very unpleasant. So again, just quick recap. Derivative of each term with respect to x. If the letters are x, you do them the same as you always do. Chain rule here, right? You got e to the u. If the letter has a y, you do it like normal, but you put a dy dx on. You multiply by dy dx. All the dy dx is on the left, everybody else on the right, and then you factor the dy dx out into the front and divide by what's there. So those dudes ended up on the bottom.